Aging, and you know that why we are including another concept, because sequence number was not serving well in a specific scenario, right? So let's see what is going to happen, right? So here again we are in the same state. Suppose the sequence number generated by this R1 is actually reached to its highest limit, which is 9999, from 0 to 9999, right? And now this guy has changed it. So what strategy R1 is going to generate here, right? So R1 also include another number, which is your age, into its LSA. This age field is actually uh, a number between 0 to 3600. And if I count this number in seconds, then 3600 means 1 hour, because 1 hour is equal to 60 into 60 seconds, which is 3600. And by the way, guys, if you have included this number age into your LSA, it keeps on increasing every second, right? So what is going to happen? Suppose when the sequence number of this message or the RSA LSA, R1 LSA was 999, suppose the age was maybe, say, okay, let's move from 0. It has recently created this 99999. So age is 0 here, exactly 0, right? And then it forwarded it here. Interesting. So when it reached to database of R2, the sequence number was, okay, I will be showcasing you here. This is the database of R2. It doesn't matter because everybody is going to have the same database. So R1 LSA is having the sequence number 99999. This was my sequence number, and the age is going to be 0, suppose. But as I mentioned, that this age is the incremental number. When you have this number in the database, right, it keep on increasing. So R1, it was 0. When it reached to R2, it is going to be 1. And then inside the database also, it is keep on increasing every second. 1 second, 2 second, 3 second, whatever, right? So we are in a particular state when the OSPF is having this R1 LSA with the sequence number 9999, and suppose the time has passed, maybe 10 minutes have been passed. If 10 minutes have been passed, then 10 into 60, basically we have 600 seconds have been passed. So maybe the age of this LSA is now 600 seconds, and the aging number is going to be 600. It is as simple as that, right? So I just wanted to showcase you that when we have the LSA, when we store that LSA into our database, the number which keep on incrementing is the age every second. And on the Cisco router, it is every second, right? It is as simple as that. If you keep it along this way, this number is going to be increased. So right now at a particular time means R1 has generated the LSA with sequence number 9999. It has sent it to R2. The sequence number is into the database of R2. And basically at a particular moment, this is the sequence number 9999 and the age value is 600. But you must be thinking, what is the advantage of it? Now try to understand the advantage. Now this guy has come and shut down this link. It means that this is no more. This link is no more. And if this link is no more, then R1 is going to generate the new LSA for R1 once again, right? And if it is going to generate the new LSA, it means that it needs to increment it to 0. So the sequence number is going to be 0 this time, right? And now the OSPF is intelligent enough to know that somebody has changed the link and I have to generate a new LSA. If I have to generate a new LSA, then I have to move back to the initial one. But it understands that if I move to initial one, then there is a problem in the network, right? Nobody is going to believe it because previously I am sending with 99999 and then I am going to send with the 0. Nobody is going to believe it, the new information. So what trick R1 is going to use? R1 says that I am going to send the same LSA, the previous LSA with the sequence number 99999 with the age value 3600. Now you must be thinking that Mr. Vishnu, link was down and you are again sending 999, and you just said that basically uh, you have to increase it, but the OSPF is using some hack, right? It is using some strategy. The strategy should be, if I want to send the sequence number 0, and if I want to make sure that everybody is going to believe that, then this 9999 sequence number LSA has to go out from the database of every router. What is the meaning of it? Why, if I send it with a sequence number of 0, why R2 is not going to install? Because it is already having a sequence number 999 LSA. And 99999 is basically higher than 0. And that is what R2 believes, right? So the OSPF now wants that whatever the LSA I have sent with 9999, the highest sequence number which I can afford, should flush out from everywhere, so that whenever I send a new message with sequence number 0, it is going to be believed by every router. It should be believed by every router, right? So how it is doing that? It is saying that I'm going to send the message with 99999, right? And the age is going to be 3600 in that. Interesting, right? And the developers of OSPF has programmed every device that if you see a message, if you see an LSA, if you see a LSA in which the aging value or the age value is 3600, just flush out that LSA from the database. And that is what exactly we want, right? Because we see the problem with the sequence number, and now we have the solution for that, that I need to program every router that if they see a packet with a sequence number 3600, it has to go out from the database. So what is going to happen? R1 is generating this message with the age 3600, right? It is reaching here, it is reaching here. R2 is going to see, okay, whatever the sequence number is, just leave it. Now the age is 3600, and if the age is 3600, I am going to flush out this LSA with the sequence number 999 out of my database. Then R2 is going to forward it, flood it to R3. R3 is going to do the same thing. R4 is going to do the same thing. Now at a particular moment, we do not have LSA of R1 in any database, in the database of R2, R3, and R4, because we just got a packet with the age value 3600, and we know, and every router knows that if it gets the age value 3600, irrespective whatever the sequence number, I do not care. I am going to flush out. I am going to take out that LSA from my routing table, and now R2, R3, and R4 is not going to have any LSA with respect to 3600 value, right? It means that LSA 9999 is out from the databases, and that is where this router is intelligent enough that previously it has sent the LSA with 3600 age value, and now it can send the LSA with sequence number 0 and maybe the age 0 once again, right? To begin with. R2 is going to receive this LSA, the new one with the sequence number 0. Now it doesn't have any choice, because its routing table does not contain this LSA, and it has to install it and then flood it. So now after some time, what is going to happen, guys? There is going to be R1 LSAs in every router's database which is having the sequence number 0 and the age 0, and of course the age is going to be increased with time. It is as simple as that, right? Having said that, I am open for questions now, guys. Although I need to inform few more things regarding the aging, but let's see what your questions are. So I can see that there are two guys who want to ask the question? And let's start with Mr. Bharat Singh. Mr. Bharat, please ask your question.
Just a clarity.
Mhm.
You said that these routers are gonna share the LSU, right? And within the LSU, the LSA will be there.
You are right.
Okay. So another question is that suppose R1 has generated a LSU. Within that, the LSA has. So if R1 has generated a LSU, that means there is a chance there might be a one or two LSAs within that router,
You are
right?
right. You are right.
Okay. Okay. So for each LSA, there will be a aging number.
Yes.
And suppose when the R1 sent it that LSA to R2,
Mhm.
the aging time, like suppose the aging time is 2.
Mhm.
When it will send it to the R2, so that when R2 is gonna start from the 2, or is it gonna start their its own aging time from 0?
No, it is not going to start from the 0. See, the age is going to be, for example, when we have here 2, actually we count the link delay also. So when we send it from here to here, the link delay by default is 1 second. So it will reach at R2 with the 3 second, and then basically it is going to start from the 3 seconds there.
Okay, so basically, all in all, like all the routers will have somehow similar aging time. Can we assume that?
You can say, but again, it depends. See, I- in this small topology, you can say that, but try to understand. When it reached to R3, it is going to be 4 seconds, right? But when it was received at R4, it is going to be only 1 second if it begins from 0, right? So maybe somewhat different time, you can say. Okay.
So, do we face any challenges in the OSPF topology in terms of conversion
Absolutely, we are, and absolutely
due
we are.
to the aging?
Yeah,
Due to
absolutely, we are going to face some challenge, and that is why basically these two numbers. And believe me, I'm going to finish that. Means right now, I have just told you the concept of 3600 seconds, why it is used, but basically OSPF floods something in the middle also. I'll let you know. But yes, you are right. But this is the time why I should tell you, I should let you know right now, right? Because this is a question. So let's try to understand what Mr. Bharat is saying. And this is a pretty genuine concern, actually, right? Let's try to understand this. So I think everybody is now okay with the fact that if I need to select a LSA, right? Or basically, if I want to move from 0, if I have moved to 999, if I want to again back to 0, then basically we need to pull out the existing LSA out of the database first, right? And that is what I'm doing with the 3600, right? So here is the problem. What Mr. Bharat is saying, that suppose you have generated an LSA from here, right? And by the way, guys, let's draw that LSU also. So this is my LSU packet, and inside this LSU packet, I have different LSAs, right? I have R1 LSA. Maybe this R1 is connected to R6 and R7. It is going to have the R6 LSA and R7 LSA. And then basically this R1 LSA is going to have its own sequence number and aging time. This R6 is going to have its own sequence number and aging time. Similarly, this one, right? It is not the case that the LSU is going to have the sequence number. It is whatever we have the LSA inside the LSU, those are going to have the sequence number and aging time. Okay. So having said that, what is going to happen now? I am sending an LSA with the value 0 here, uh, with the aging value 0 here, and R2 is going to install this into its database, right? And suppose the value here is sequence number, suppose it is maybe 200, and the age value, suppose here is 5, or maybe 0 to 1 second, right? Similarly, when we reach here, this guy is also having the sequence number value 200. It is not going to be changed because there is no change. And then basically the age value may be, suppose here, 2 seconds. right? And then similarly here also, we are having this thing, sequence number 200, and the age value is going to be 2 seconds, suppose. Maybe 1 second here. As I mentioned, this value is going to be increased every second. And now this guy is quiet for a while. Suppose this guy has gone for the lunch, so he is not disturbing your network. So we are good. Maybe the network is up and running from last couple of hours. Then what is going to happen, guys? This edge is going to be continuously increasing, right, inside the database. And after half an hour, what is the age? After half an hour means 13 to 60. It means that approximately 1800 second here, 1800 second here, right? 1800 second here, because this number is continuously going to be changed. As simple as that. What is exactly going to happen after 1 hour? Just try to understand. This value is going to reach 3600, guys, right? Maybe 1 second below, this value is going to reach 3600. And here again 3600. And if the value of the LSA's age reach to 3600, what we have programmed the router to do? We need to flush out this LSA. Does this mean that the OSPF topology is going to be there in consistent state for 1 hour? Right? We all know that if this age value reaches to 3600, then it's a problem. The problem is every router is going to flush out this LSA because it says that it has reached to the maximum age. If you reach to your maximum age, you know what is going to happen, because right now I do not know what is my maximum age is. But if somebody is saying that your max age is Vishnu, maybe 75 years, then I should know that after 75 years I'm going to die. What is the meaning of dying of LSA here? The meaning of dying of LSA here is that it should be out from the database table, right? If that is the case, after 3600 or after 1 hour, this OSPF topology is going to be highly unstable because everybody is going to flushing out. But yes, all these things are not synchronized, guys. It is not like that the time it happens on the basis of time. So maybe the router 1 LSA is aging out at some different time as compared to R4. So the mechanism used by OSPF is, and it is very, very interesting thing to know, that it knows that after 1 hour, my LSA is going to be flushed out. So I need to take some immediate step. And what step it is going to take? That R1 knows that when it has generated its own LSA, right? After 30 minutes, after every 30 minutes, R1 is going to generate this LSA again, right? And flood it everywhere. It means that after 30 minutes, irrespective of the change, guys, believe me, there is no change. There is absolutely no change, right, in the topology. But still, after 30 minutes, OSPF is going to regenerate this LSA and going to send it, right, with the same sequence number. And if that is the case, then what is going to happen, guys? R2 is going to get the another sequence, R2 is going to get the another LSA. It is going to see that, okay, it gets the another LSA. So what exactly it does is, whatever the timer going on, it should be somewhere in the 1800 after half an hour. It is as simple as that. So it is going to reset this value and nothing else. Because of course, 200 sequence number was already there. So what it is going to do, it is just refresh the value. It makes it 0. It start counting again from the 0 because it knows everything is cool. No problem with respect to that. But yes, there is the period where after 30 minutes, and you have heard about it, that after 30 minutes, actually OSPF is going to refresh right? This is the meaning of refresh. The meaning is basically the existing LSAs which are in the database table of everybody, they should not reach to 3600. If that is the case, then basically those are going to be flushed out because you have programmed the OSPF in this way. Why you have chosen 3600 time to get the flush out? Because there was a problem with the sequence number 0 to 3600, right? 0 to 999. If I want to move again to 0, you understand what is the problem, right? But this is the problem because aging is again going to be continuing in a particular router. And if that is the case, then R3 is going to uh, R3 is going to reach 3600. And if that is the case, then basically it is going to flush out. So try to understand. We solve one problem, but it can have impact on other functionality, right? Then we need to solve there also. It all begins with which LSA is more recent. We need to find out on the basis of sequence number, but sequence number were causing some issue when they reach to maximum. That is why we introduced the concept of aging, that if somebody is having 3600, flush it out. And because of it, if the if the LSA reaches to 3600, because this age is incrementing, it means that it is again causing the problem. And that is why we have the refresh time of 30 minutes, so that everybody should not reach to 3600 in its database, and we do not need to reflood it. It is as simple as that. I think the answer was slightly long, but I believe, Mr. Bharat, you got your answer, right? Mr. Burak.
Yes, I got the answer, but it has raised one more concern. Like,
But we will be discussing this, Bharat. Let me talk to Burak and Vishnu, and then we want to complete one more board, and then I will come to you. Okay?
Okay, thank you.
Mr. Burak, your question now.
Okay, thank you, Vishnu. Does R1 sending this LSA alone or within the LSU LS updates message?
Yeah, the LSA, see, as we discussed, it is very important to understand that we have only 5 messages type in in OSPF. One is hello. The second one is link state update. The third one is link state acknowledgement, right? Then database description message. What was the fifth one, guys? Anybody can remind me?
Request.
Yes, link state request. So it means that there is nothing called LSA which can go from R1 to R2. It has to be between these two, right? Between these 5. So as I mentioned, that LSU contains multiple LSA, and it could be the case this R1 is connected to some more routers, right? So it definitely is going to have its own LSA R1, but it is connected to R6 and R7. It is going to be there. So instead of sending one LSA at a particular time, they have created a link state update message which can carry multiple LSAs. Okay, Burak?
Yeah. Sure. Another question is, we have talked about the master and
slave.
The master, yes, master and slave, and the master is increasing the sequence number.
Yeah,
in this example,
I would like to stop you exactly at that moment, right? See, the concept of master and slave was there when we were initially bringing up this neighborship. Okay? And then basically the concept of master and slave, when we are doing the Xstart phase, right? And that is where we were choosing master and slave so that we can decide that who is the initiator going to be for who can change the sequence number of database description message, not the LSA. So here, what is the sequence number of database description, right? That is totally different. Now we are talking about an LSA sequence number, which is inside LSU, right? There the process is, so do not confuse this sequence number with this one.
Mm-hmm.
We have included the sequence number here so that because we do not acknowledge the database description message. So what we were doing there is sequence number 10, and if this guy slave has sent me back the packet with its own DBD, right, with sequence number 10, then I'm pretty sure that if that guy is sending me the sequence number 10 back, then basically we are good. This is used as an acknowledgement mechanism. So in database description packet or in master slave or during the neighborship process, we were using the sequence number of database description as an acknowledgement, right? But here the things are completely different. So do not get confused with these two things.
Yeah,
These
yeah,
are totally different.
yeah.
Okay.
I understand. Thank you.
Perfect.
Mhm.
So Mr. Vishnu, your question now.
Yeah, hi, sir. So one of my question is actually answered about the sequence number. I was about to ask, we will see sequence number only in the DBT packets and where else, but you were clearly explaining that LSUs will have a sequence number as well.
Yeah.
So that question is sorted. With that, I have one other question.
Mm-hmm.
So where would this LS updates or LS requests would be sent? Is it like a multicast address or the point-to-point address? Because I was actually doing some packet capture and then I was able to see both.
Yeah, and this
Initially,
this is pretty interesting to know because as we move in the development of OSPF, we are improvising, right? Suppose try to understand. At the end of the day, suppose I have this R1 router and I have this R2 router, right? And they are connected over the point-to-point link, or maybe the broadcast link. The first hello is going to be on, you all know, 224.0.0.5, right? And your observation is absolutely correct. When we started developing it 40 years back, then the reply packet was again coming to 224.0.0.5. But right now, try to understand. If you get the hello from R1, right, it is going to include the source IP address also, right? And if that is the case, then you can send it as unicast. So there are two RFCs, and do not get confused with them, right? We are improvising on that. So previously this was the case that everybody is sending on 224.0.0.5, but then there is improvement comes that it is similar to ARP also, right? Address resolution protocol messages send it as a broadcast, but when we get the reply back, it is the unicast, right? So in the latest development, basically, and the latest development is also 10 years old, you can say, or 20 years old, we can see. So your observation is absolutely correct. Means sometimes, but the first packet should reach there so that we can send back the unicast. Okay. So if you see that, that is fine. That is perfectly fine. Okay, Vishnu?
Yeah, okay, sir.
Yeah. But this is good. And this is absolutely fantastic that you guys are creating your own lab. You guys are seeing the packet because this should be the approach of learning, right? So everybody, whoever is here, please make sure you create the lab. And this is very, very simple, right? What you need to do, you just need to enable OSPF. And how to do that, I will be letting you know. So with that, guys, we have seen that we had broken the problem of OSPF into multiple pieces with this hammer, and we are learning these pieces one by one. Neighborship done, flooding done. Although I'm not saying that flooding is completely done, but as I mentioned, that if you want to go into the depth of 100 kilometers, my responsibility is to walk you with 20 to 25 kilometers, and that portion is done now. But if you want to study more, if you want to finish the process of flooding, right, if you want to study more and more, then even this flooding process can take means 2 or 3 classes, right? I do not want to do that. If you want to, now you have a solid background understanding of this flooding process, you can go and read on its own. But believe me, for your project's understanding, for doing the real life project, you do not need even more than that. So done.